Okay, thank you very much for coming to this session about testing. I'm going to show you some tricks today to develop tests that makes your tests easy to write, but more important, make them easy to read. I'm going to just start with unit tests and end up with deployment tests. And the theme that I've chosen is about composers and operas. So I think that it's quite easy to understand. My name is Alex Soto. I work in Red Hat, and I'm the author of Testing Java Microservices for Manning. And please, if you have any question during the session, just raise your hand, and I will try to answer it, basically because if you ask me just when you have the question, then we have the context, so I don't need to remember where I was talking about at that point. Let's just start with assertions. I think that all the tests has assertions. If they don't have assertions, then you have a problem, because they will be always green. And the most important things about assertion is that verifies the logic under test, and any reader is the thing that makes him easy to understand that test. And let's see an example. This is a JUnit test. Probably 95% of you are using JUnit and not test-ng, so I put in the examples with JUnit. And let's start. The first thing that you will notice is that I use should as a start work, because a test might pass or not. So it's interesting to put should instead of must. And also I'm using this underscore thing instead of camel case. This is because usually I prefer to write long method names that describe the purpose of the test. So using underscore, it's better for the human brain rather than camel case. The next thing that you'll notice is that I'm using BDD style. Although this is not a BDD test, this is a unit test, I really like to put my test in several blocks with given and when and then. So anyone can just identify each of the parts. And now it comes the assert part. And in this case, I'm using the assert equals method, which is provided by JUnit. And the first thing that you'll notice is that when you talk, you say, I want that this value is equal to the expected value. But this is the common language. But if you get the assert equals, you see that this is on the other way. You put first the expected one, and then the actual one, which is not so good. And the other thing that you might notice is that assert equals uses the equal implementation. And the problem with equal implementation is that might be good for business purposes, but maybe it's not good for testing purposes. And I'm thinking, for example, of getting null pointer exceptions, or I'm thinking when you want to write assertions for collections, where the order is important and the equals of the objects inside the list is also important. So how to fix this? Well, for assertions, instead of using handcrest or the JUnit keyword, I prefer using AssertJ. AssertJ is like the best of handcrest and fixes the wrong things of handcrest. And one of the good things about AssertJ is that it's a DSL, so it's IDE friendly. So you can just do assert that, put there the actual value, and then push Control space. And AssertJ is smart enough to detect the type of your object and provide the assertion that has sense for that object. And this is, again, an example. It's the same example, but using AssertJ. The first that you need to take care is importing this static method instead of the assert equals from JUnit or handcrest. This is assert that, but it comes from the assertions package. Notice that now the methods are really readable. You said assert that moser.getName dot, so it's first the actual and then the expected one dot, is equal to Wolfgang Amadeus Moser. So it's quite better than the previous one. Also, you can check that you can say assert that Mozart returns Wolfgang Amadeus Moser, and then if you are using Java 8, I'm using here the method reference. So what's going to happen here is automatically SurgeA will call getName and will assert that the call of getName to the Mozart object returns Wolfgang Amadeus Mozart. But in these cases, it's using the equals implementation. If you don't want to use equals implementation, you can use these two methods, which is equal to comparing field by field. So it's going to compare field by field all the objects. Or if you said, yeah, but I know that there are going to be null objects there, and I don't want to take into consideration, I can use the to ignoring null fields. So then you can compare your object without thinking equals into the assertions. And what is even better is when you start working with collections. Notice that now operas is a list. So if I put there a list and I do dot and control space, it will provide me some methods that are specific for collections. In this case, for example, there is the hash size, which I check that the hash size is 2. The other thing that I can do is just calling extracting. Extracting, it's just, okay, take me the list of operas, call me the getName method, and get me a list of strings with the names of all the operas. And finally, this returns a list of strings, and I can do contains exactly in any order. Of course, I can do contains exactly in order, contains, and so on and so far. And so you can see that this is really neat test. And if you think about how you will implement this in Hamcrest or in GNU, you already see the advantages of using SurgeA. And notice that now the extraction returns a string. So the contains exactly in order, it expects to receive a string, not any other object. Another thing that has SurgeA is the soft assertions. And basically, what it does is doing something like this. You do soft assertions dot assert softly, and then this provides a Java 8 Lambda method. And it executes all the assertions of this block. But if you compare this with the previous runs, if one assertion, for example, the first one fails, then this test fails. And the rest of the assertions are not executed. With soft assertions, what's happening is that, okay, I'm going to execute the first assertion. If it fails, okay, I'm going to store the result, and I will continue executing all the assertions. So at the end of the test, if there is a failure, it will fail the test, but you will be provided with a report with all the assertions results. So it's quite interesting because sometimes when you change something in the business code, you said, oh yes, I didn't remember to update the test. So you run the test, it fails the first assertion, you fix it, then you run again the test, and said, oh, now it fails the third one, I need to fix it, run again the test, and so on and so forth. So with this approach, you can fix all the problems in once. Easy. The other thing that happens usually is that your code, it's really beautiful and it works, but sometimes you need to throw an exception, and you need to test how these exceptions are treated. So one way to do this with JUnits, it's just doing the try-catch method, which, as you can see, it's not really beautiful. It works, of course, but you see some things like given when, then in the catch you have the then, which is not quite readable. And one of the things that is really, for me, it's really funny is that the test, not the test, the method passes, but then it fails. So it's quite strange because it's like, okay, it worked, but it didn't work because I failed. So it's not quite intuitive for a reader. And the other thing to do is just do this thing. You say, okay, I'm going to do test, and I use this expected attribute where I put the exception that I'm expecting. Again, the problem is, okay, it's like given when. So what is the then? Okay, there is no then. Well, for a reader, it might sound strange, then can look up and say, oh, yes, there is an expected keyword. The other problem is that who throws this illegal argument exception? Maybe it's the constructor. Maybe it's the find composers by name. I don't know. Is there real illegal argument exception that I expected? Maybe find composers by name throws two different illegal argument exceptions. Is that the one that I expected in this test or not? So yeah, it's not a really good approach to test exceptions. Again, SurgeA has a really good way of checking this exception code, following the given when-then, but now in when, you use that catch-throwable static method. This catch-throwable is just a Java 8 Lambda expression where you put the method that you expect to throw the exception. And finally, in the assert that, you can do things like is instance of illegal argument exception. So now you know which method has thrown the exception, which is the exception, and finally you can do with fail message, which you put there the message that you're expecting. So with SurgeA, you know exactly who throws the exception, when was thrown, and what was the message. And you're following the BTT style, which is quite good. So to finish the SurgeA, one of the benefits of SurgeA is that IDE friendly. Just as you said, go there, put the jar on your IDE, and start doing control space, and you will see all the suggestions. There is also an assertion generation, which basically generates code. Code with assertions of your POJOs. There is a plugin for all the IDEs, NetBeans, IntelliJ, Eclipse, also for Maven plugin, Gradle plugin, and plugin, which you set where are your POJOs, and they will start generating all the assertions for that POJOs. So you can do something like, in this case, assert that Moser has name Moser, has birth date, and so on and so forth. So it creates all the assertions for all your POJO attributes. And following this philosophy, it provides for you SurgeA some out-of-the-box assertions for WABA collections, for Joda time, for databases, for Neo4j, and for Swing. The next part, or next problem that you might face is not for unit tests per se, but probably for integration tests, component tests, end-to-end tests. And it's about waiting and not sleeping. This usually happens if you are writing UI tests, that you have your browser and you send something to the browser and said, yeah, when I push this button, I need to wait until some kind of information is printed on the browser, so you need to wait there until something is printed. Maybe if you are using a GMS queue, in your code, you push something to that queue, and then this queue will react and do some logic. But it's an asynchronous logic, so you need to wait until this logic has happened. And also, in case of you are using reactive code, you also face this kind of problems. So how to do this? Well, this is more or less the same example as before, but now I introduced a gramophone class. Basically, gramophone is a method which starts a new thread, takes the opera, finds the opera on disk, and sends the opera to the player. So when you finish the play method, the song is not still being played. So what you do is like, okay, since I know that in my computer it takes like 1 second to start playing the music, I'm going to put 3 seconds, just to have some merge in there. Then I push this code to my CI environment. My CI environment is slower than my computer, and the test fails. And I said, okay, I'm going to put it 5 seconds. You put 5 seconds, then CI passes, then this code is pulled on another work main machine, it starts, and then with 5 seconds it still fails, so it puts, okay, I'm going to put 10 seconds. Yeah, it's a good approach. So you have here the slowest machine time. So my machine that is really fast and executes this with 1 second, I need to wait every time 10 seconds. To fix this, we have a utility. A utility is a DSL that allows you to express expectations of an asynchronous system, and it looks like this. We still have that gramophone.play, but now we are using this await method. This await method is a static method from a utility, and what it does is like polling every 100 milliseconds until gramophone is playing returns true. And it will wait at most 5 seconds. So at the end, we can consider that you, at the end, wait the time that is required by your machine. Easy. Benefits of a utility is that you also have that deadlock detection. you can use different polling strategies. I've seen that now we are using a fixed polling, which means that it's like every 100 milliseconds, it starts polling if the gramophone is playing until it returns true. You can change the defaults as well. But this is for fixed strategy. But yes, also there's other polling strategies like Fibonacci. So you can do something like wait 1 second or 1 millisecond, then wait 1 millisecond, then 2 milliseconds, then 3 milliseconds, then 5 milliseconds, then 8 milliseconds. It follows the Fibonacci series. Also, it has the iterative way. So basically, there you can put your mathematical expression there. So you can do something like wait 100 milliseconds, then twice, which is 200, then twice, 400, and so on and so forth. Or even you can implement your own polling strategy. And one thing that I really like, and nowadays this people doesn't care a lot, is that has no external dependencies. There is no magic. This is a simple while implemented, so it's really easy to debug, really easy to add in your project. So it's a really good testing jar for your project. Let's move higher level. Let's move to black box testing. And it's about how to test REST APIs. Probably you are using REST with XML and JSON, or JSON, although you can using binary protocols. And let's see how you can test your REST API. Now, suppose that I have this endpoint, which is a get, and I do a slash, and I put the name of the composer, and it returns all the information about the composer. You see that it returns simple objects like the name. And also it returns arrays, which is all the operas that compose, which is, this is a really true example because Beethoven only wrote one opera. So one way to write your REST API test is like this, using, in this case I'm using, I thought that this example was with Apache client or Apache Commons HTTP client, or yeah, well, this Apache HTTP thing. And you can see that first I need to prepare the connection, which is setting the URL and setting the path. Then I do the connection, so I just send request, don't use the get with all this stuff. Finally, I get the content that is returned by the HTTP client. And finally, start manipulating the strings. Of course, you can use some kind of JSON libraries to parse this, but it's not the purpose of this test. I mean, that just to show you that at the end you need to manipulate the strings. And yeah, maybe you might say, oh, it's okay, this test. Yes, it's okay, of course. But if you check it more deeply, you see different level of abstractions of the test. You are preparing the connection in one place, you are doing connection, you are manipulating the strings. So at the end, this test does a lot of high-level operations and low-level operations at the same method. This is really funny. I've seen this on production, and it's using WebDriver to verify a REST API. So basically, you start a Firefox browser, you do the path, and then you get the response from the browser. It's just like funny how people think about resolving common problems. But I think that the best tool for testing REST APIs in Java is RestAssured. And basically, RestAssured is used for testing and validating REST services, and it's inspired by the Ruby frameworks for testing REST APIs. And this is a really simple example. Notice that I start with given. Given is a static method provided by REST API. So then I call get, because I want to use the get HTTP method. And notice that now I can use a placeholder. So I could put here my string directly, but you can also use a placeholder. You put composers, and then you put the substitute of the placeholder. By default, REST API, RestAssured connects to localhost 8080. This is the default URL. And finally, I do assert that, the body, and then the first parameter of the body is a JPath expression. JPath expression is like XPath for XML, but for JSON. So you can see now that I'm asserting the name is Ludwig van Beethoven, and I'm using gpath expression for operas.size is equal 1, sorry. So this is a gpath expression getting the size of the collection. And finally, I can get it operas.name, that remember that operas is an array, so this method just returns an array of the strings of the name of all the operas. And in this case, it just has one item, which is Fidelio. Of course, in the previous example, I showed you that it connects to localhost 8080 by default. So one way to configure to connect to another host is just using this thing. So you just hard code the URL in your get method. This is one way. The problem is that you are not going to deploy all the time into example.com. Maybe sometimes it's example.com, but maybe sometimes it's in your pre-production URL, maybe sometimes it's my local environment, so you need a way to dynamically change this. And to do this, RestAssured has this request specification builder and request specification class, which basically allows you to reuse the same configuration across all the requests. And you can reuse the expectations. So if sometimes all your REST APIs has the same expectations, you can put it there. Also the path, the port, the host, the parameters that need, the header that you need, or even the authentications methods that we are going to talk in the next slide. So here I'm using the spec builder. I put my host, and then I reuse there everywhere. So this request spec builder is like it's put in a static factory, and then I can get it from all my tests and just do .build, and then the RestAssured will be configured with these parameters instead of the default ones. And finally, you've got the RestAssured out, which probably your REST APIs are secured, and you are thinking about, oh, and then I need always to put on my code given, blah, 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 do all the stuff related with the security, and then start the calling. You don't need to do this because RestAssured provides the most common authentication methods: basic, digest, form, CSRF token, OAuth 1 and 2, and even you can implement your own authentication method. So, for example, in case of OAuth, you can do given.auth OAuth2. You put there the access token, then .when, and then you can do .get, and you start putting your URL of your business code. So in this way, you don't need to take care about authentication things. So one of the more features and benefits of RestAssured is that it allows you to implement your custom parsers. So it's not just for JSON XML. If you're using any binary protocol, you can implement your parser there. This is really cool. This SSL support. Usually when you start dealing with HTTPS, you start with certificates that are not authenticated, certificates that are expired, certificates that are not trusted, and so on and so forth. So with RestAssured, you can just do relaxed HTTPS validation and just forget about all the problems with the HTTPS certificates. You can also implement filters. So before sending request or before getting the response, you can modify the elements. And one thing that it's not widely used, but it's quite interesting, is that it implements the JSON schema validation. And this is basically JSON schema is an RFC for defining the schemas like XSD, but for JSON. And this is really interesting when you don't care about the content. You just don't care about the structure of your JSON document. So you can use RestAssured to say, I don't care if the name is Ludwig van Beethoven or Mozart or whatever. What I care is that there is a field that it's name and it's of type string. And this is what RestAssured can do as well for you. Just you provide the JSON schema and he validates automatically for you that this schema is valid. Let's start with maybe something more related to microservices dependencies. And I put microservices into parentheses because at the end, although you have your monolithic application, probably you are connected to other services like, I don't know, Twitter or your mail server or a payment gateway or whatever. Basically, we're going to see how to test code that connects to third-party services or internal services if you're using microservices approach. So what are the problems that you may face when you want to test services? Well, the first one is that the network might be down. And your test may fail because the network is down. Or the service that you want to connect is down. So you're going to get a failure, not because of your test, but because when you want to connect, it's failing. Also, maybe because the limits of the API. So if you, for example, want to connect to GitHub or Twitter or whatever to do something, you've got a limit on the requests that you can do per day. So your test might fail because of this problem. Also, one important thing is that the company is not in your control. The service, although this internal service, probably is not developed by you, but by another team. So he can decide to change anything. So your test might start failing because someone changed something in the external service. And finally, something that I call microservices dependencies hell. And this is like if you are using it or you are developing a true microservice architecture, you're going to have hundreds of services. And these hundreds of services, each service might have persistence storage as well. So if you want to run your test, you might need to start up a service, the service that you want to connect. This service might contain persistent storage, so you need to start his persistent storage. But this service maybe connects to another service, so you still need to run or start this other service. And at the same time, this service can connect to another service, and so on and so far. So you have a graph of dependencies, and you need to start all the graph of dependencies to make your test run, which you end up by doing an end-to-end test, and at the end it's like, okay, my test is going to be a flaky test, always, and at the end you're going to ignore the test because it's the safest thing to do it. So possible solutions to this is mocking the HTTP component. So probably you have a gateway class, which is the one that is responsible for talking with your other service, and it uses some kind of HTTP library and so on, so you mock this HTTP library. This is good for unit tests, although in fact you need to do this for unit tests, but not for integration tests, because if you do this in integration tests, you are not testing the full stack calls. So if you're using HTTP client and you mock the HTTP client, all the configuration related to HTTP client, all the calls of HTTP client are not going to be done. So maybe you find some surprises when you deploy this to production. Another way is using an stub fake HTTP server, which is, okay, I'm going to take my HTTP server and I'm going to pre-program some request and response. So I have my gateway that connects to this, not a proxy, but this fake HTTP server and provides me some responses. And that's a good approach because you are testing the full stack. But the problem is that this stub HTTP server is how you understand the other server, not how this other service is really implemented. So it's your understanding, not the real way. So the solution for all these problems is using service virtualization. And service virtualization is a light proxy that intercepts requests and response in a smart way. So it's like the fake HTTP server, but it's quite more intelligent. And it has two running modes. One is capture mode, and the other one is the simulate mode. And let me show you both of the modes. The first one is the capture mode, and it's usually run the first time that you run the test. So I have service 1 that wants to connect to service B. So what I do, the first thing is just connect to the proxy. Instead of connecting to service B, I connect to my proxy. This proxy will say, okay, this is the first time, and I am in capture mode, so I'm going to go to the external network and touch the real service B. If in this case the service B is down, okay, bad luck. Yeah, we cannot do anything. But probably it's up and running, so it's going to return the real data. then this data is going to be stored on a database. In fact, it's a file, but you could choose a database or any other backend. And finally, the service A receives the real response. So now you're effectively running against the real service. So you get it, real request with a real response. Then, the next time you run the test, the service virtualization like proxy starts in simulate mode, which basically says, okay, service A, I want to connect to service B, no problem, connects to the proxy, and the proxy says, you have already done this request for me before. So I'm going to the scripts, I'm going to get the real response that I recorded before, and I'm going to get it back to my proxy and return to you. So now you've got, let's say, the best of the both worlds. You've got an stub HTTP server in the sense that you're using the full stack, and at the same time you are using real data, not data that you thought that it was valid. And to do this, I think that there's several implementations. Probably most of you have knows about WireMock, for example. But I think that one that is really, really cool, and you'll see now why, it's Overfly. Overfly is implemented in Go, but it's integrated with Java with a JUnit rule. And one of the best things that it has is that it modifies the JDK proxy settings automatically for you. So you don't need to touch anything. Any communication that goes outside the JVM, it will pass through the Overfly proxy. And this is an example. First of all, it starts Overfly. And I started in capture and in simulate mode, which means that Overfly will check if the getComposers.json file is present. If it's present, it will start with simulate mode. If not, it's going to start with capture mode. Then I put here my Composers gateway, which is the one that connects to the Composer server, and I put operas.com 8080. And notice that this is the real host. I'm not putting their local host or any other internal host. It's just the real host. Then I get data from the real call, from the real server. And this is how the getComposers look like, which is at the end is a JSON where you record the path where you've done the request, and then the method, the destination, more parameters, and then the response is all the response that it's been returned from operas.com. And what is the funny thing is that now I can run again this test, and I'm getting data from the proxy. But notice that the host is still the same. I don't need to change anything. Although I can see here that I put operas.com, my code is not going to connect to operas.com. It's going to connect to my proxy and return the data. And that's really cool for your test, because you're abstracting from where the service is running. So yeah, it's, I think that in this case, service virtualization might simplifies a lot all your service integrations. Then we have another kind of external services, which are the persistent tests or your backends. That at the end you have databases, NoSQL or SQL databases, and they need to, that you can consider them as a service, and they need to be tested as well. And the problems with persistent tests is that are really easy to break, because by nature, persistent data is stateful because it's stored somewhere. And it means that you don't have isolation between test methods. So one method can insert something, and other tests can get this something as well. So usually this problem, you might have it with inserts and deletes against the database. So what you need to do is maintain your database in a clean state. And to maintain your database in a clean state, you can do something like this. Prepare the database. So the first thing that you do in my test is just clear the database. So if I have nothing, then I'm sure that I know exactly the state of the database, which is empty. Then I insert the data that I expect to be there. Then I execute the query. And notice that in all these places in clear database, in insert composers data, and also in define composers by name, I'm dealing with SQL queries all the time. All the time I'm executing SQL queries. I mean, the problem is not executing the queries, but maintaining the queries. And then I execute the query, and I get the result, and I check that the name is the one that I expected. So you can see that there is a lot of boilerplate code, because you need to do this clear and insert for all your persistent tests. And you need to maintain the SQL sentences, and so on and so forth. So there is our Killian ape. Our Killian ape is one part of the Killian ecosystem that removes all the boilerplate code of your persistence test. And it's called ape because it's our Killian persistence extension, but we commonly name as ape because it's like doing tasks that even an ape could do it. And basically, the only thing that you need to do is, first of all, you define a rule. If you are using our Killian for any other things, our Killian usually use a runner. So if you are using runner, you don't need to put the rule. But if you are using other runner, like for example, the Spring Boot runner or whatever, you can use the rule approach. Finally, you said that you want to use the DB unit to search. In this case, I'm testing for SQL databases. So I've said, okay, I want to populate data that are in form of DB unit. Then I configure the connection and so on and so forth. So I can do something like dbms populator dot for URI. I put the URI where my database is running. I put the driver, I put the username, the password, and then I set the data set. That is the one that I want to populate inside my database. And then I call execute, and this thing is going to populate all my data that are on composers.yaml. And composers.yaml looks like this. It's a YAML file. And notice that this is not the standard DB unit format. In fact, we support the XML DB unit format, but since it's writing data sets with XML, it's quite painful. We are also giving support for YAML, for Excel, and for JSON. So in this case, I'm setting composers is the table, and then I put all the attributes that I want to insert into the composers table, which is ID, name, birthday, and when it died. But you need to remember that you need to clean your database. So first of all, for example, you can create the after annotation in JUnit, which means that it's executed after every test. And finally, I call the clean method, which removes everything from the database. So with just this call and the other call and creating a YAML file, you don't need to worry about maintaining the database into a known state. No SQL sentences to maintain, no boilerplate code in all your tests, and so on and so forth. So the benefits of our Killian is that you don't have boilerplate code. Here I, yeah, sorry.
Are you able not to repeat your configuration for the data using the before and after you showed?
Yeah, actually, this is true, but you can put this inside a factory or a static class. I mean that, notice that in the previous example, you have the clean, and then you have the insert. And the insert might be different depending on the test. So you need to, this insert method, you need to do copy-paste from the other test, or you end up by copy-paste from the other test and just changing the SQL. In this way, you only need to, only need to have a factory class where you pass the YAML file location, and then you can reuse the same and just changing the file. Yeah, but yeah, at the end you need to do something. This is not entirely true, and I'm going to explain now, because now I've shown you the programmatic way, but you also have the declarative way, which instead of having to do this programmatic way, you can annotate your test with using data set, and you put there the string, and then you can do should match data set, and you put the string that you would like to match after the test. So with just putting these annotations to your test, you'll get it the same thing. But personally, I prefer the programmatic way, because I don't like this kind of magic. Yeah, because if it fails, you don't know where to search. And finally, yeah, we have SQL support for DB unit and also for Flywave to migrate the schema. So you can even put, you can use flyway annotation, and then you have a RDBMS populator that instead of receiving a DB unit files, it receives flyway files. Also, NoSQL support for MongoDB, Couchbase, CouchDB, Bolt, Redis, and Finispan. So you can do exactly the same, but for NoSQL databases. And finally, this is really cool, is that sometimes your service depends on another service, okay? And you need to populate this service. And we have also support for REST APIs. Basically, it receives Postman collections. So you set a Postman collection there, and then before executing your test, our Killian app will load the Postman collection and populate it to that other service. So you have the service B, which is called the provider, with a known state as well. And that's all for persistent, and then let's move to even more higher tests, which are containers. Maybe you're using containers on production, then you need to test that this production are able to start and the Docker file is working. Or maybe you're just using containers or Docker containers for testing purposes. You're not running on production with Docker, but your test runs with Docker, so you can start up and shut down the databases, the mail servers, and so on from a Docker container, which is easy for everyone to do it. So the way to test it is just doing something like this. You can do a Docker build, you create your service, and then you do the Docker run, and then when you have this Docker run, your container running, then you go to your IDE and you do play and execute the test against this service. Or you can do a Docker Compose app if you have a Docker Compose file. Then you run Maven clean test, right? Because you want to execute the test against these boot up services. And finally, you need to stop the containers. And of course, this is manual steps. Of course, you can put it on your build tool, all these steps as well. So you do Maven clean test, and then your build tool will start or execute the Docker Compose thing, execute the test, and then stop doing the Docker Compose stop. The problem that you might have with this approach is that first, it's not really natural for a developer, because as a developer, you want to be in your IDE, do right-click on your test and say, run the test. If you do this from your IDE, you're not going to have the Docker containers up and running. And for example, also, you cannot debug, because you're in, well, actually you can if you start using remote debugging and so on, but it's quite more complicated. And one thing that you might face is that you might have IP problems. If you're in Linux, your Docker containers are running in localhost, but if you're in Mac or Windows, probably your containers are running in a boot to Docker instance, so it's another IP. And my IP is not the same IP of my workmate. Or even maybe my Docker host is a remote host. So yeah, in all these cases, you need to have some kind of configuration, or you might have some configuration problems. And for the reason, we have our Killian Cube, which is another piece of our Killian, which manages everything from Docker. So one of the things that you can do is just put a Docker Compose file. Our Killian Cube will read this Docker Compose file, will start all your containers, then it will execute the test, and then stop the containers. And it works as a suite level, so you can decide that for the whole suite, I want to start once the containers. Maybe I can also put, I want to start the containers for each test method, or I can even connect to existing Docker containers. Other thing that you might, that offers Cube is that all the configuration things are managed automatically, so you don't need to take care of the IP. You can inject the Docker host IP on your test automatically. And it doesn't matter if you're using a Docker host on your local machine, or in remote machine, or in Docker machine, it doesn't matter. Our Killian Cube will take care of everything for you. And yeah, and let's see, this is an example. I'm using a Killian Runner here. This is because if you want to use the Docker Compose approach, you need to use the Killian Runner. And the other thing that you can see here is that it has an integration with RestAssured, so I can put a Killian resource, Docker URL, and I put the container name and the exposed port, right? Then what's going to happen with our Killian Cube when you run this test is like, I'm going to read Docker Compose file, I'm going to start all the containers defined in the Docker Compose file. Then I'm going to create a request spec builder. This class is the RestAssured class with the IP to connect to Hello World container and with the binding port of the 8080 exposed port. So since the binding port might be random, even in these cases, our Killian Cube will inject you here the real IP and port to connect to that service. And finally, it's just a normal RestAssured call. And you can do it without any problem because this request spec builder is prepared to connect to the Hello World service. And in this case, the Hello World or the Docker Compose file looks really simple. And if you put it in source test Docker, then it's picked up automatically by Cube. You don't need to configure anywhere where this file is stored. Of course, you can even use our Killian Cube DSL, which instead of creating a Docker Compose file with all the containers, you can programmatically define your container. And in this case, this is a Spring Boot test, so I need to put the Spring Runner. I need a custom initializer because I'm going to use, or this test originally used Spring data. So if you want to configure Spring data with the 4 ones, you need to put an environment variable. And with, if you're running on a Spring Boot test, you need to create a custom initializer to set this environment variable. Finally, I define the container that I want, and in this case, I'm using the DSL approach and the DSL and rule approach because I cannot use the Killian Runner. And I do container DSL rule. I put here the container that I want to use. In this case, it's the Redis. And then I define the port binding that I want to use, that is 6379. Then I create my initializer, which is the one which is going to initialize the environment of the test. So Spring Data Redis are able to connect to that Docker instance. And I create, well, I call it test containers. And notice that it's important that I can do Redis. This Redis is the container DSL, that it's the class rule. And I can do get IP address and get binding port. And again, this is the IP and the port that you are able to connect to this container. And that's all. If you do this test is going to be a Spring Boot test. It's going to start Spring Boot, a start Redis container. This Spring Boot application is going to be configured to connect to the container created here, and then the test might be run. And last but not least, last thing, is I would call it the mother of all tests, which is the deployment test, which is like what we have seen now, but now instead of being a Docker Compose, it's a Kubernetes.json file. So probably if you're using Docker on production, you're deploying in Kubernetes or OpenShift or Google Cloud Engine or whatever. And this is for you. It just reads the Kubernetes.json, deploys all your services defined in Kubernetes.json, or in all the inclusions that you have there, deploys all of them, runs the test, and then it removes this from the test. So you can get it the Kubernetes client if you want to interact with the cluster. You can even get the URL to connect to a service. So in this case, if you want to connect to a service called Hello World Service, you do this. And this URL will contain the URL to connect to that service. And also we are providing a custom assertions to get that all your infrastructure is up and running correctly. And in this case, I would say that just this line fixes 90% of the problems that you might face in Kubernetes. It just checks that after 30 seconds, the pod is up and running. Then it will wait for 10 seconds pinging if the pod is really up and running, because usually the pod is up and running and then after 2 seconds it dies. It happens because you've done something incorrect and then the pod just dies. Then with just this line, you will get it that if it passes, you know that this pod is up and running and ready to serve requests. So let's read down. We have seen from low-level to high-level tests, from unit, component, integration, deployment tests. We have seen that it's not just for microservices. You can use it also, a lot of this concept for your monolithic applications. And one of the important things that I tried to say is that with all these libraries, what you're improving is the readability of your tests, and which is really important because the tests, you write once, but you need to read it a lot of times, usually when they failed. And that's all. This is a QR code where you have the link of the presentation, link of the book I've written, blog post I've done about Spring Data tests, Spring Data microservices, and so on and so forth. And in any case, I will post the slides on my Twitter. Thank you.